Welcome back. In the previous episode, we set up the player game object. And in this episode, I will give you a brief introduction to programming with C#. First, let's check what code editors are available. Open Edit, Preferences, and from there, External Tools. Here we have External Script Editor field. It is probably set to Visual Studio. It doesn't really matter, but we will be using Visual Studio. If you have another program to write code with, you can use it. Next, let's create a folder and name it Scripts. Select the player game object. Press Add Component and choose New Script. Name the script as Player with uppercase P. Note that it's important to start script names with an uppercase letter. Press Create and Add. This will create a script to the Assets folder. Click and drag the script to the Scripts folder we created. Now, select the player. The script has been added to the player as a component. Next, open the script by double-clicking on it in the project window. If you are using Visual Studio and your editor looks different, you might be using a different theme. If you wish, you can change the theme from Tools, Options, General, and from there, Color Theme. Dark is a good theme for eyes. Up here, you can see the file name of the script, which should be player.cs with uppercase P. And on line 5, you have public class player. Here, player is the class name. The class name and file name must match, or Unity will not recognize this as a script. The coding language we will be using is called C#. When you begin writing C# code, there's a lot of concepts that might confuse you at first. For example, what are all these using lines at the top for? Or what does the void before the start mean? And what does the public class player Modifier mean? It will be easier to learn if you ignore most of them and focus on the basics. Before going further, let's look at comments. We already have 2 comment lines in the file before start and update. Lines are commented by adding 2 forward slashes in a row. Anything after the slashes in the line will have no effect in code, so it is a good way to write notes for yourself and others. Next, let's take a look at variables. What are variables, and how do you define them? Variables store data, but they must always have a type that tells what kind of data. The type could be a decimal number, a whole number, piece of text, a game object, a transform component, rigid body component, a script component, and so on. You don't have to repeat the following steps that are done in this episode, but if you want to practice, you can repeat them. Now I will give you an example of a variable. This is how we would define a variable called lives. You can ignore the public part, as it will be explained later. First, when defining a variable, we need to tell the type. Here the type is int, short for integer. Then you have the name of the variable. You can assign almost any name of a variable. However, it is good to start the name of a variable with a lowercase letter. Also, you should avoid the names of any existing types functions, keywords, and so on. For example, trying to name the variable as int would cause an error. A variable of type int will only store whole numbers like 3, -12, or 0. And here we have defined the value of lives to 3. Notice the semicolon at the end. Semicolons mark the end of a statement, so you need them at the end of most lines. There are many more types of variables. Here are some examples. This variable is of-type float that stores decimal numbers. Floats are specified by adding an f to the end of a number. Next, I will add a string variable. String types store text. The text is specified between double quotes. Then we have the Boolean. Booleans can only be true or false. Also, I will add a vector2 variable. Vector2 holds two float values that represent a 2D vector's x and y value. Vectors are used as positions and directions. You probably noticed this, new vector2. This is because it is a type provided by Unity and needs to be constructed. It will be explained later. Now I will add a rigid body 2D variable. This can hold the rigid body 2D component we added to the player. Note that I didn't give a value to the variable. It isn't needed. Now, let's see what the public part does. Public is an access modifier, but simply it tells if other scripts can access it. There are a couple of them, but public and private are the most used with Unity. Public means it doesn't have any restrictions, so anyone can read or change the value. Private, on the other hand, means that only the script that defines it can see it. In Unity, there is an additional use for access modifiers. If you have a variable set as public, you can see and change it from the inspector window. So we'll save the script now and switch to Unity. When I select the player, I can see all of the public variables in the player script. I can also change their values as I like. If I would start play mode, the variables would start as defined here on the inspector. The values given inside the script are only the default values, so they have no effect if you change them in the inspector. If I change one of these variables to private and save, we can see it in Unity that the variable disappears from the inspector. Next, let's take a look at functions. In C#, you would call them methods, but for simplicity, we will call them functions. Functions are a block of code that can be called to execute the code inside them. This script already has two functions, start and update. These are Unity-specific functions. Start is called at the start of script's lifecycle, that is, when a script component is loaded in the game. That could be the start of a scene, for example. It is useful to set up variables, like searching for components. I will give you an example. RB equals getComponent rigidBody2D. In start, we search for a rigidBody2D component in the same game object the script is in. I will also make a comment for an example. Now I will show you a useful way to find info about Unity-specific scripting. If I select the Get component, for example, and press Help, Unity API references, Visual Studio will open up the search results for Git component from the documentation. We can see several Git component functions. If I open one of them, it will show information and examples of the function. I can next search for Rigid Body 2D in the search area and open the first result. This will show what Rigid Body 2D contains and what you can do with it. You can also use the web version of this API that will most likely load faster than the local documentation inside Visual Studio. Let's look at the update function next. Update is called every single frame of the game, so it is useful to handle the game logic from here. Let's look at an example of writing simple C# logic inside update. Here we have an if statement. If statements are used to run code only on certain conditions. For example, the code between the two curly brackets would only run if isAlive boolean was false. Now, I will show you an example how to take one life away from the player. Lives equals lives minus 1. This would now run every frame when the player is dead. So I'm going to set the isAlive boolean to true again. isAlive equals true. I'll also move the player to the spawn position variable that was defined above. Transform .position equals spawn position. Here I'm using the transform component of the game object. If you remember, transform takes care of the position, rotation, and the scale of the object. The position is of type vector 2, so we can set it to spawn position, which is also a vector 2. It's also important to reset the movement speed of the player when it spawns, so it won't keep accelerating. rb.velocity equals new vector 2, 0, 0. Here, when I'm setting the value, I used the new keyword. Variables have to be constructed before they can be used. Types like int, float, and string can be set directly because they are built-in C# types. But vector2, for example, is a custom type by Unity. The new keyword creates a new vector2, and the constructor takes two floats to tell what the x and y values are. We won't go deeper into constructors now though. Next, I will save the script and go to Unity. I make sure that the player is selected and I start play mode. Now we see all the public variables. Also we see that the RB variable is now set, since the start function searched for a rigid body 2D component. If I click the isAlive box, the player loses a life, teleports to the spawn position, and sets isAlive to true again. Now I will go back to the functions. First, you have the keyword void. Functions can return values, and you specify the return type here. Void simply means that there is no type and the function doesn't return anything. After the return type, you have the function name. After the name, you have the function parameters inside the parentheses. Update has no parameters, so they are empty. And finally, you have the block of code that will run. Blocks are defined by having curly brackets. Lastly, let's take a look at scoping. If I were to define an integer inside the update function, I could use it inside the update function but nowhere else. This is because of scoping. If you define a variable inside a function, the variable scope is limited to the block. Simply put, if variable is within a scope, you can use it. Now we are done with the introduction, so I will clean all the temporary code. This might still feel confusing, but practice makes perfect. In the next episode, we will make the player move when we press buttons from the keyboard. See you in the next episode.